When selecting the appropriate conductor size for an air conditioning unit, several factors must be taken into consideration. The most important factor is the ampacity of the conductor, which refers to the maximum amount of current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate conductor size based on its ampacity. For aluminum conductors, Table 310.15b16 is a crucial reference. This table provides ampacity values for various conductor sizes and insulation types at different temperature ratings. The specific insulation type, such as XHHW, affects the conductor's ampacity. XHHW insulation is a widely used type known for its heat and moisture resistance. It is important to use the correct ampacity values for the specific insulation type being used. In this case, we are considering #6 XHHW aluminum conductors. According to Table 310.15b16, #6 XHHW aluminum conductors have an ampacity of 55 amps when rated at 75 degrees Celsius. This means that the conductor can safely carry up to 55 amps of current without exceeding its rated temperature. The load that the conductor will be carrying is a 50 amp split system air conditioner. Therefore, the conductor must be able to safely carry at least 50 amps. Based on the ampacity of #6 XHHW aluminum conductors being 55 amps, they would appear to be sufficient for this application. However, there are other factors that must be considered, such as ambient temperature and termination temperature ratings. The ambient temperature is the temperature of the environment in which the conductor is installed. If the ambient temperature is higher than 30 degrees Celsius, a correction factor must be applied to the conductor's ampacity. This is because the conductor's ability to dissipate heat is reduced at higher ambient temperatures. 110.14 Kinitwo of the National Electrical Code addresses termination temperature limitations. This section of the code requires that the terminations of the conductors be suitable for the temperature rating of the conductor. Specifically, it states that equipment terminations for circuits rated 100 amps or less, or marked for #14 to #1 aluminum conductors, must be used with conductors rated for 60 degrees Celsius or 75 degrees Celsius. It is important to check the equipment specifications to determine the temperature rating of the terminals. If the terminals are only rated for 60 degrees Celsius, the ampacity of the conductor must be based on the 60 degrees Celsius column in Table 310.15b16. This will typically result in a larger conductor size being required. If the terminals are rated for 75 degrees Celsius, the ampacity of the conductor can be based on the 75 degrees Celsius column in Table 310.15b16. In this case, the #6 XHHW aluminum conductors are rated for 75 degrees Celsius, so this rating can be used if the equipment terminals are also rated for 75 degrees Celsius. If the ambient temperature is 30 degrees Celsius or less, and the equipment terminals are rated for 75 degrees Celsius, then the #6 XHHW aluminum conductors are sufficient to wire the 50 amp split system air conditioner. However, it is important to always verify the specific requirements of the local electrical code and the equipment manufacturer's instructions. The National Electrical Code specifies minimum requirements for electrical installations, but local codes may be more stringent. It is also important to follow the equipment manufacturer's instructions for proper installation and wiring. In addition to ampacity and temperature correction factors, other factors to consider when selecting conductor size include voltage drop and dating. Voltage drop refers to the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code provides guidelines for minimizing voltage drop. Dating refers to the reduction in ampacity that is required when multiple conductors are bundled together in a raceway or cable. This is because the heat generated by the conductors is not able to dissipate as easily when they are bundled together. The National Electrical Code provides tables for determining the appropriate dating factors. In summary, When selecting the appropriate conductor size for an air conditioning unit, it is important to consider the ampacity of the conductor, the ambient temperature, the termination temperature ratings, voltage drop, and dating. The National Electrical Code provides tables and guidelines for determining the appropriate conductor size based on these factors. It is also important to verify the specific requirements of the local electrical code and the equipment manufacturer's instructions. Let's delve a little deeper into each of these considerations. Ampacity, as we've established, is the current carrying capacity of a conductor. It is directly related to the conductor's size and material. Larger conductors have lower resistance, allowing them to carry more current without overheating. The material of the conductor also plays a crucial role. Copper, for instance, has a higher conductivity than aluminum, meaning it can carry more current for the same size. However, aluminum is lighter and less expensive, making it a common choice for many applications. The National Electrical Code, or NEC, provides detailed tables that list the ampacity of various conductors based on their size, material, and insulation type. These tables are a critical resource for ensuring safe and compliant electrical installations. Ambient temperature refers to the temperature of the surrounding environment in which the conductor is installed. This temperature can significantly affect the conductor's ability to dissipate heat. Higher ambient temperatures reduce the conductor's heat dissipation capacity, effectively lowering its ampacity. The NEC provides correction factors to adjust the ampacity of conductors based on ambient temperature. These correction factors are essential for ensuring that conductors operate within their safe temperature limits, especially in hot environments. Termination temperature ratings are the maximum temperatures that the terminals of electrical equipment, such as circuit breakers and disconnect switches, are designed to withstand. It's crucial to select conductors with temperature ratings that match or exceed the termination temperature ratings of the equipment. Using conductors with lower temperature ratings than the equipment can lead to overheating and potential failure of the connection. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can negatively impact the performance of electrical equipment, causing it to operate inefficiently or even fail. The NEC provides guidelines for limiting voltage drop in electrical circuits. These guidelines typically recommend limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, larger conductors with low resistance can be used, or the length of the circuit can be shortened. Dating is the reduction in ampacity that is required when multiple conductors are installed together in a raceway or cable. When conductors are bundled together, they generate heat that can be difficult to dissipate, leading to overheating. The NEC provides dating factors that must be applied to the ampacity of conductors based on a number of conductors in a raceway or cable. These dating factors help to ensure that conductors operate within their safe temperature limits when installed in close proximity to each other. Now let's apply these concepts to the specific scenario of wiring a 50 amp split system air conditioner with #6 XHHW aluminum conductors. First, we need to consult Table 310.15b16 in the NEC to determine the ampacity of #6 XHHW aluminum conductors. As mentioned earlier, these conductors have an ampacity of 55 amps at 75 degrees Celsius. Next, we need to consider the ambient temperature. If the ambient temperature is 30 degrees Celsius or less, no correction factor is required. However, if the ambient temperature exceeds 30 degrees Celsius, we need to apply a correction factor to reduce the conductor's ampacity. For example, if the ambient temperature is 40 degrees Celsius, the correction factor for #6 XHHW aluminum conductors is 0.88. This means that the conductor's ampacity is reduced to 55 amps multiplied by 0.88, which equals 48.4 amps. In this case, the #6 XHHW aluminum conductors would not be sufficient to carry the 50 amp load of the air conditioner. We would need to use a larger conductor size, such as #4 XHHW aluminum, which has an ampacity of 65 amps at 75 degrees Celsius. We also need to consider the termination temperature ratings of the equipment. If the terminals of the circuit breaker and disconnect switch are only rated for 60 degrees Celsius, we must use the 60 degrees Celsius ampacity rating for the #6 XHHW aluminum conductors, which is lower than the 75 degrees Celsius rating. This would likely require us to use a larger conductor size as well. Finally, we need to consider voltage drop in derating. We should calculate the voltage drop in the circuit to ensure that it is within acceptable limits. If the voltage drop is excessive, we may need to use a larger conductor size or shorten the length of the circuit. We also need to apply derating factors if multiple conductors are installed together in a raceway or cable. In conclusion, the suitability of using #6 XHHW aluminum conductors for a 50 amp split system air conditioner depends on several factors, including ambient temperature, termination temperature ratings, voltage drop, and derating. It's essential to consult the NEC and follow the equipment manufacturer's instructions to ensure a safe and compliant electrical installation. Remember that electrical work can be dangerous, so it's always best to consult with a qualified electrician if you have any questions or concerns. Always prioritize safety and follow all applicable codes and regulations. Let's consider some practical examples. Imagine an air conditioner being installed in a hot attic where the ambient temperature routinely exceeds 40 degrees Celsius. In this scenario, the ampacity of the #6 aluminum conductors would need to be significantly derated due to the high ambient temperature. This would likely necessitate the use of a larger conductor size to safely carry the 50 amp load. On the other hand, if the air conditioner is installed in a cool, well-ventilated area where the ambient temperature remains below 30 degrees Celsius, the #6 aluminum conductors may be sufficient, provided that the termination temperature ratings of the equipment are also compatible. It's also important to consider the length of the circuits. Longer circuits will experience greater voltage drop, which can negatively impact the performance of the air conditioner. In long circuits, it may be necessary to use a larger conductor size to minimize voltage drop and ensure that the air conditioner receives adequate voltage. The NEC provides formulas and tables for calculating voltage drop in electrical circuits. These calculations can help determine the appropriate conductor size for a given circuit length and load. In addition to the NEC, local electrical codes may also have specific requirements for conductor sizing. It's essential to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. The electrical inspector can provide guidance on conductor sizing, grounding, and other aspects of the electrical installation. Grounding is another critical aspect of electrical safety. The grounding system provides a low-resistance path for fault current to flow back to the source, which helps to protect against electric shock. The NEC specifies the requirements for grounding electrical systems and equipment. It's essential to properly ground the air conditioner and all associated electrical components to ensure safety. In summary, selecting the appropriate conductor size for an air conditioner is a complex task that requires careful consideration of several factors. These factors include ampacity, ambient temperature, termination temperature ratings, voltage drop, derating, and local electrical codes. It's always best to consult with a qualified electrician to ensure that the installation is safe, compliant, and performs optimally. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always prioritize safety and follow all applicable codes and regulations. Regular maintenance of the electrical system is also essential. Check connections for tightness, inspect conductors for damage, and test the grounding system periodically. Proper maintenance can help to prevent electrical problems and ensure the long-term reliability of the electrical system. Finally, it's important to keep accurate records of all electrical work. This includes conductor sizes, circuit breaker ratings, and other relevant information. These records can be helpful for future maintenance and troubleshooting. By following these guidelines, you can ensure a safe and reliable electrical installation for your air conditioner. Now let us also imagine if the conductor was run underground. If the #6 aluminum conductors are installed underground, the ampacity may be affected by the soil temperature and moisture content. The NEC provides tables for rating conductors installed underground based on these factors. Underground installations also require special considerations for corrosion protection. Aluminum conductors can corrode in certain soil conditions, so it's important to use conductors that are specifically designed for underground use and to provide adequate corrosion protection. Furthermore, if the air conditioner is a high-efficiency model with a variable speed compressor, the inrush current may be significantly higher than the running current. Inrush current is the momentary surge of current that occurs when the air conditioner starts up. It's essential to select conductors and circuit breakers that are capable of handling the inrush current without tripping or overheating. The equipment manufacturer's specifications will typically provide information on the inrush current requirements. Also, consider future expansion. If there is a possibility that the air conditioner will be replaced with a larger unit in the future, it may be prudent to install larger conductors now to avoid having to replace them later. Oversizing conductors can also reduce voltage drop and improve the efficiency of the electrical system. In addition to the technical considerations, it's also important to consider the aesthetic aspects of the installation. Concealing conductors and equipment can improve the appearance of the installation. However, it's essential to ensure that concealed conductors are properly protected and accessible for maintenance. The NEC provides guidelines for installing conductors in concealed locations. Furthermore, consider energy efficiency. Using energy-efficient conductors and equipment can reduce energy consumption and lower utility bills. Energy-efficient conductors have lower resistance, which reduces voltage drop and power losses. Energy-efficient equipment, such as air conditioners with variable speed compressors, can significantly reduce energy consumption. Also, consider surge protection. Power surges can damage sensitive electronic equipment, such as air conditioners. Installing surge protection devices can help to protect against power surges and prolong the life of the equipment. Surge protection devices should be installed at the service entrance and at the equipment itself. And think about harmonics. Nonlinear loads, such as variable speed drives, can generate harmonics in the electrical system. Harmonics can cause overheating of conductors and equipment, as well as other problems. If harmonics are a concern, it may be necessary to install harmonic filters to mitigate their effects. Another consideration is labeling. Properly labeling conductors and equipment can help to prevent confusion and errors during maintenance and troubleshooting. Labels should be clear, durable, and easy to read. The NEC provides guidelines for labeling electrical equipment. Also, consider coordination. Coordinating the circuit breaker ratings with the conductor sizes and equipment ratings is essential for ensuring safety and preventing nuisance tripping. The circuit breaker should be sized to protect the conductors from overcurrent, but it should not be so small that it trips unnecessarily. Finally, consider documentation. Maintaining accurate documentation of the electrical installation is essential for future maintenance and troubleshooting. Documentation should include conductor sizes, circuit breaker ratings, wiring diagrams, and other relevant information. In summary, selecting the appropriate conductor size for an air conditioner is a multifaceted process that requires careful consideration of numerous factors. By taking into account all of these factors and consulting with a qualified electrician, you can ensure a safe, reliable, and efficient electrical installation. Let's revisit the core question of whether #6 aluminum conductors are sufficient for a 50 amp air conditioner. The short answer is that it depends. It depends on the ambient temperature, the termination temperature ratings of the equipment, the length of the circuit, the rating factors, and the local electrical codes. It's impossible to provide a definitive answer without considering all of these factors. The NEC provides the guidelines and tables necessary to make an informed decision. However, it's always best to consult with a qualified electrician to ensure that the installation is safe and compliant. In addition to the technical aspects, it's also important to consider the human element. Electrical work can be dangerous, so it's essential to follow safe work practices and to use appropriate personal protective equipment. Always de-energize circuits before working on them and use a voltage tester to verify that the circuit is de-energized. Wear safety glasses, gloves, and other appropriate PPE. Be aware of your surroundings and take precautions to prevent falls and other accidents. And always work with a buddy. Another person can provide assistance in case of an emergency. Moreover, it's important to be aware of the potential hazards of electricity. Electric shock can cause serious injury or death. Arc flash can cause severe burns. Electrical fires can cause significant property damage. It's essential to take precautions to prevent these hazards. Use properly insulated tools and equipment. Keep a safe distance from energized equipment. And never work on electrical equipment when you are wet or tired. Electricity is a powerful force that demands respect. By following safe work practices and taking precautions to prevent hazards, you can work safely with electricity. Finally, remember that electrical codes and standards are constantly evolving. It's essential to stay up to date on the latest requirements. Attend training courses and read industry publications to keep your knowledge and skills current. By continuously learning and improving, you can provide safe and reliable electrical services. In conclusion, the decision of whether to use #6 aluminum conductors for a 50 amp air conditioner is not a simple one. It requires a thorough understanding of electrical codes and standards, as well as careful consideration of various factors. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can make an informed decision that ensures a safe, reliable, and efficient electrical installation.